Okay, we're back. Welcome to another exciting Java class. Today I think we had some homework that was due, and I believe we were calling this one homework 4. Is that right? Or homework 3? Operators was due today. Homework 3. Did anybody have any questions about their operators at homework? Easy, right? In the next chapter, which is chapter 4, it covers base conversion. And base conversion is sometimes termed radix conversion. The base usually refers to the base of the numbering system. We humans normally have 10 fingers, and so we are very used to what is known as the base 10 numbering system, but the common name, of course, is decimal. So we are all trained from grade school to use decimal. And one of the characteristics of a numbering system with a specific base is it defines the total number of symbols. So when you think about base 10, the number of symbols that you have to deal with in that base is 10. But it starts with 0. 0 is a proper numeric symbol. And if we think in terms of what it takes in order to represent base 10 numbers using what's called positional notation, we classically refer to exponents. Exponents allow us a little bit of, I would call it, flexibility in terms of changing our numbering system. Let's see if I can do, I wanted to build a little bit of a, I'll call it an experiment I needed a web camera, and I kind of wanted it sort of in a hurry. And so this is my web camera in a hurry system. There you go. Web camera in a hurry. Can you see that okay? It's sort of a little washed out. Maybe I can do something about that. That's a little better. You can see that okay? Could be bigger, but it's all right. You can see from that. So what I thought I would do is, see, the trouble is, if I turn the lights out so that you can see the screen, then I cannot see the paper. So it is an engineering trade-off, you see. So what I thought I would do is introduce you to this basic idea of positional notation. And so in positional notation, I will represent a number 110. What is the value of 110 in base 10? It's a trick question. You cannot know with the information given because you do not know the base. The only way for me to take 110 and interpret it in its context, which is let me give you the context. The context is we're doing a lecture on base number conversion. So if somebody says 110, how do you know if this is base 2 or base 10? 110 in base 2 is a completely different number from 110 base 10. 110 could be base 7. 110 could be base 8. 110 could be base 3. No one knows what the base is. So the answer is, what does it equal? We don't know, right? We can't know. But if I said to you 110 base 10 is equal to what quantity base 16, well, that's a very different problem, isn't it? That's not the same. It's different. And if you needed to do that conversion, you might not know how to do that right offhand. But that might be a perfectly reasonable test question. And in fact, you would encounter this in any Digital Design 1 class. And certainly if you were programmers, you'd want to be able to know how to do the conversion. So let's talk about the value of 110 base 10. If I represent this in positional notation, it's equal to 1 times 10 to the 012 plus 1 times 10 to the 01 plus 0 times 10 to the 0. This falls out to 0. This comes to the value 10. This comes to the value 100. And that gives us 110, or 110 base 10, which is fine. I like that. So now the question remains, how would I get 110 base 10 into another base such as 16? Let's assume we're not using computers for the moment. We're just using, well, we are using computers. It just so happens that the computers are between our ears. So we're using our brains. So just using our brain, I think we can make this conversion happen. Well, the first thing I would like to do is see if I can do a base 10 to base 2 conversion. That's interesting. How do I convert from base 10 to base 2? You guys are up on the reading, right? Yes. Someone said least common division? Least common magnitude? Multiplication? Here's how I do it. 110, I have my own little technology here. I divide by 2. And so 2 goes into 11, perhaps 5, with 1 left over. And then it goes in 5 again. And then there is 0 left over. And that goes in the least significant bit. And then I do it again. And so 2 goes into 5, 2, with 1 left over. And then 7, with 1 left over. Right? Then I do it again. 2, I get 1, and then 3, and 1 left over. If it's odd, there's always going to be 1 left over. And so now I have 6 with 1 left over. And then I have 3 with 0 left over. And then I have, am I going down to the end? Oh, I have to watch what I'm doing. Then I have 1 with 1 left over. And now I have 0 with 1 left over. And now I can represent, I'm not sure that my little USB web camera is working out so good. So now I'm going to represent my little number here as 110111 base 2 equals 110 base 10. Isn't that interesting? Because the symbols are all 1 and 0, yet the values are the same. And the other interesting thing is the number of digits is quite different. Now, let's go back to the original question, which was back on the top, and it says 110 base 10 is what number base 16? Well, in order to do this conversion from base 2 to base 16, I like to group. I group in 4 bits at a time because it takes 4 bits to represent a single hexadecimal digit. And then I go back all the way to the top and I review the hexadecimal digit to base 10 conversions. A is equal to 10, B is equal to 11. Is this too small for the back? You're kind of far away back there. C is equal to 12, D is equal to 13, E is equal to 14, F is equal to 15. If you were to write this out, oh, where am I? Right here. If you were to write this out, I'll see if I can find the edge of the screen here. A, B, C, D, E, F. Okay, so that's F because it fits. So F this will be in radix 16 on the left, and we'll write it in radix 2, also known as binary, on the right. And so now A is going to be equal to the number 10 in decimal, and 10 is going to be an 8 plus a 2, and so that's 10. 1 0 1 1 1 1 0 0 1 1 0 1 1 1 1 0 1 1 1 1. So this is probably familiar to some of you. You've seen all that junk before, right? Very, very similar. So now let's go back to the original question. How do I convert 1 1 0 1 1 1 base 2 into another number, and we'll say in base 16. And so now if we say, aha, 0 1 1, that's going to be a 7, and then a 1 1, that's going to be a 3. So we write out 7 3 base 16. Now the question is, how do we know if this is true? We can use positional notation. 7 times 16 to the 1 plus 3 times 16 to the 0 equals 7 times 16 plus 3. And if we look at 7 times 16, and 3, it's not a correct number. Did I do 7 times 16 improperly? 6 times 7 is 42. 7, 8, 9, 10, 11. Yeah, it's not correct. So I made a mistake somewhere. This should be a 3. Oh, and that should be a 3, not a 7. So it's 3 and 7. I got it backwards. Thank you. Yes. So ignore this. Garbage that. Garbage that. And now we'll rewrite it. So 1 1 0 1 1 1 base 2 equals 3 7 base 16. That's better. So now we have 3 times 16 to the 1 plus 7 times 16 to the 0, which is equal to 3 times 16 plus 7, which is equal to 6 times 3 is 18, carry the 1. 3 plus 1 is 48 plus 7. That's 55. Also not correct. Did I make a mistake here? 1 2 3. 1 2 3. Oh, you know what? I missed a 0. Here, check it out. It was 1 1 0, 1 1 1, and then a 0. Ah, so easy to make a mistake. Let's do it one more time, only this time with a little bit more authority and a few less flubs. I'm not used to doing this thing with the web camera, because you have to keep rewriting stuff. So what we have here is, in binary, 1 1 0, 1 1 1, and then a 0. That's so important, that extra 0, isn't it? So now if I convert that to hexadecimal from base 2, 1 2 3 4, form a vertical bar. So this is now 0, 2 to the 0, 2 to the 1, 2 to the 2, that's 4, plus 2 to the 1. So we're calling this 6. And this number over here, we're calling E, because there's E, 1 1 1 0. And if you wanted to, you could come up with decimal equivalents on all of these things. 10, 11, 12, 13, 14, 15. So E corresponds to a 14. So what I have here is 6 times 16 to the 1 plus 14 times 16 to the 0. And this must be equal to 6 times 16, whatever that is, plus 14. How much is 6 times 16?
96.
96 plus 14. So now it looks like it's 110. Paste 10. Thank George Boole. Glad we got that one right. 110 is base 10. That's 110 decimal. And I know it's 110 decimal because I started with 110 decimal. I converted the 110 decimal into binary by using repeated division. The least significant bit comes up on top. The most significant bit comes up on bottom. And then I kind of have to look over here on the screen while I'm doing this because I want to make sure you're seeing it properly. And then what I did was I wrote it horizontally with the least significant bit on the right and the most significant bit on the left. And then I proceeded to, by grouping, convert this into hexadecimal. Then I looked up the hexadecimal symbols, converted them to base 10. That's also known as decimal. Rewrote them in positional notation. And then I proceeded to write out the original number. So if you think about it, I had several procedures. I started out with radix 10. I converted to radix 2 using repeated division, RD, repeated division. I used the radix 2 to radix 16 conversion by using grouping. So I did group by 4 bits at a time. Then I went from radix 16 over to radix 10 using positional notation. PN, positional notation. So this is an interesting point. The technique you use will be a function of which radix you're converting from and which radix you're converting to. Isn't that interesting? So suppose I took this same number. Let's look at this number we had from before. 110, 1110, base 2, which we happen to already know is equal to 110 or 110 base 10. Suppose I said to you, well, I'm really interested in programming my old PDP-8 computer. PDP-8 computers you probably have never seen, but they have blinky lights and they work in 12-bit codes. Well, as a result, they group the 12 bits in groups of 3, which means that people commonly program the base 8 into the PDP-8, hence the name. So if you think about it, you've got something here in base 2. How do I convert it to base 8, which, by the way, has a common name? It's called octal. Yes. So how do I go from base 2 to base 8? Could you say it louder? I've got a buzzing projector up here. Yes, group by 3. So I go 3 bits from the right, another 3 bits from the right, and now when I convert to base 8, I do it by inspection. So then this becomes a 6, this is a 5, and then this is a 1. And now when we write 156, it's so important that you write the base, because if you write the wrong base, you're going to have a wrong value. So technically speaking, 156 could represent any number. without the base, we cannot know. So when I ask you a question, how much is 111 or 110, the answer is you didn't give me enough information because you didn't tell me the base. So now I have 156. Suppose I have 156 base 8, and I want to convert it to base 10. That is decimal. What do I do? Oh, my computer is sleeping. All I hear is murmurs. Graduate students with big shot engineering undergraduate degrees. Convert it to binary. You could do that. And then convert it back to decimal? Okay. You could do that. I got a better way. Want to see? It's positional notation. 1 times 8 to the 0, 1, 2 plus 5 times 8 to the 1 plus 6 times 8 to the 0. So what I've done is I've used the 0th place to represent the exponent, the first place for the exponent here, the second place for the exponent there. If I write it out, it now becomes 64 plus 5 times 8 plus 8 to the 0 is equal to 1. So now I have to write 6. Does it come to 110? I hope so. Okay, you guys will have to help now. 5 times 8 is? It's how much? 40. Oh, good. Just checking. Plus 6 plus 64. Let's see now. 64 plus 40, that must be something like 104 plus 6, which is equal to 110 base 10. So I didn't have to convert to, oh dear, I went off the screen again. I didn't have to convert to binary at all. I could use positional notation, which means if I want to go from base 8 to base 10, I can use positional notation. So now, if I write R8, Pn. In fact, if you think about it, you can go from any base to base 10 using positional notation. That is, using the exponent of the base and the position of the digit, you can determine what the exponent should be when you raise the base to that power. So that's a very compelling and interesting and wonderful argument. Maybe a powerful way to go. Let's try another exercise. So across the top, I will write some numbers, which you cannot see. There they are. 10, 11, 12, 13, 14, 15. Okay? In hexadecimal, I will write, oh, it's coming off the top. A, B, C, D, E, and F. Okay? Suppose I said to you, oh no, my computer is D, E, A, D, base 16. How much is that worth to you in base 10? Okay. So now we use our positional notation. We see, aha, D is equal to 13, E is equal to 14, A is equal to 10. So we say D is equal to 13, so 13 times 16 to the 0, 1, 2, 3 plus 14 times 16 to the 2 plus 10 times 16 to the 1 plus D, which is equal to 13 times, 13 times 16 to the 0. Got that? You can kind of see why you really don't want to do PowerPoints with this. It's much better to see people to show how to develop the equation than to just flash the PowerPoints up and everybody goes, oh yeah, that makes sense. Because then you never really get it. So I could write this out, or I could get my little calculator. 16 to the 3? That's some big number, I don't know. Let's see, 16 to the 3, what could that be? Do you guys have calculators? I think there's one built in. Calculators. Yes, here's one. Calculator. 16. It's how much? 4096? 16 to the 3 is correct. 4096. That's right. Okay. So now it's whoa. I made this on my kitchen table this morning. Maybe it's not such a good one, huh? I could spend the big bucks, but Amazon says it takes 2 days and class is today. So who can wait 2 days? So now I have 4096. I was trying to use my iPad to do it, and iPad makes a terrible makes a terrible tablet. 4096 times 13. Oh, that's a huge number. I wrote 16 though. Times 13 plus, I think it's 14 times 256 plus 10 times 16 plus 13. Some big number, huh? All for dead. Keep in mind that base 16 is a more efficient way to code large numbers than base 10 because you can use larger values with fewer symbols. So it makes sense that you can represent relatively large numbers with fewer symbols. I'll give you an example. F, 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 F. Base 16. That's only 4 digits, but it is 65,530. I'm going to say 535. So, in fact, it uses slightly fewer digits than the base 10 equivalent. So whatever this comes out to, if you wrote it just that way on a test, that would be good enough. You don't actually have to sit there and run the computations. In fact, you could even write it just that way, because the more interesting thing is that you're able to set it up, not that you're able to compute 16 cubed or something. I mean, who cares about that? So going from base 16 to base 10, we would use positional notation for that. Going from base 8 to base 10, we use positional notation for that. Going from base 2 to base 10, you could use positional notation. Suppose I said 1101 base 2 is equal to what number base 10 in positional notation? Well, it's 1 times 2 to the 0, 1, 2, 3 plus 1 times 2 to the 2 plus 0 times 2 to the 1 plus 1 times 2 to the 0. Strictly speaking, you could say, aha, I can do a lot of this in my head. But when you're doing it in a test or in front of a class, you would not do that. So then I could write something like this. 1 times 2 to the 3 is the same as 8 plus 4 plus anything times 0 is 0 plus 1. So perhaps the number is 13, base 10. What do you think of that? Now, if you wanted to, you could say, hey, wait a minute, 13 base 10, I know that. That's equal to D. and D is equal to 1101, which you can see from here. So then if you went back, you could go and you could say, aha, look at that, 1101, it's D. So you could have done it that way too, but it doesn't work very well in general, especially for large numbers. If you've got large strings of binary, I would encourage you to convert them to a simpler base, either base 16 or base 8. Either is fine, and you can do it directly by examination after grouping. Not to put too fine a point on it. Suppose I said FED base 16 is equal to what number? Base, make up a base. How about base 8? Ah. Now we're going from 16 to 8. Now what do we do? Binary and then group. That sounds good. So now if I do it to binary, it's 1111, and then E, which is equal to 1110, and then D, which is equal to 1101, and then I take this and write that in binary. Now I take the binary, group by 3, and I get a number 7755, base 8. What do you think of that? Directly by inspection using the grouping from base 2 into base 8, that's pretty easy. So by going to base 2, I can really regroup to base 8 or base 16 with relative ease. Relative ease. Okay, so now what? We've gone, we've got our little conversion recipe here. I've got a chart like this in the book. But now if I wanted to go from base 8 to base 16, I would do it by grouping. If I want to go from base 16 to base 8, I do it by grouping. If I want to go from base 16 to base 10, I do it by positional notation. In fact, I can go from any base to base 10 using positional notation. Huh. Okay. So suppose I said to you, that's just great. So here's a number, 127 base 10. What's that number equal to in base 8? How shall we approach this problem? You can use positional notation? Well, now let's see if that's true. Positional notation says this is equal to 1 times 10 to the 0, 1, 2 plus 2 times 10 to the 1 plus 7 times 10 to the 0. How does this help me? What does this do for me? I'm stuck and I'm running out of time and I only have an hour to do the test. Oh no, you've wasted my time because you told me to do the wrong thing. So what can I do? Positional notation, it didn't help. Convert to binary and then group by 8. That will work. That will work. It's going to be a little bit of a hassle, isn't it? Because 127 divide by 2, that's 6, 3, carry 1. 2, that's going to be 3, 1, carry 1. 2, that's going to be 1, 0, carry 1. Wait, 1, 5, carry 1. Oops, I forgot the carry here. 1, 5, carry 1. 2 is going to be 7 carry 1. 2 is going to be 3 carry 1. 2 is going to be 1 carry 1. Who thinks of such examples? This is a devilish example. And so then 2, it's going to be 0 carry 1. Oh my heavens. It's all ones. It's all ones. So now I have to group by 3. 1, 2, 3. 1, 2, 3. And now this looks like a 1, 7, 7. And so now the output should be 177 base 8. So now I can write it over here in the corner, 177 base 8. So that's a way to do it. Isn't there a better way? Huh. Maybe not. No, I like this way. You could probably do it using repeated division by the base that you're converting into. So you could do repeated division by 7. No, by 8. But then if you do that, the division gets rather much harder. But it's not terrible. But I like the other way, dividing by 2. It's always going to yield you a correct result. Plus it gives you a binary number which you can use for other bases if you need to. So that's pretty good. So now if I look back, what we just did here was we converted from base 10 to base 8. So to go from base 10 to base 8, we found a path. We went to radix 2, and then we grouped by 3. I'll just write G by 3, G times 3, group by 3. So that's a legitimate way to go. Going to base 16, we group by 4. Going to base 8, we group by 3. Easy to remember. Do we need another example? No more examples? You're done. You're expert. So now it's time for a test. We can all take out a piece of paper and work these problems on our own. Yes? Want to try? Okay. So what we'll do is we'll start off with a number. Let's see if this works. I'm thinking of a number. Oh, I know. 314, which feels like the beginning of pi. And I will call it base 10. And I want to convert it over into base 2. Why don't you guys work on that for a little bit? And it's not a race, but the first person to finish wins. So when you're done, you can raise your hand. I'll work on my end of it first. I'll write it down in here. I'll do my little answer. Oh, you're done already. Okay, what did you get? 100 111 Very good. I think that's looking right. Anyone else getting it? Go ahead. You got the same. How do I know you didn't copy him? Anyone else get it? Is it correct? Yes? So we're all getting it. That's good. So with 111010, what would I get for base 8? I got 72. You have 111010. That's 3 ones. So that's a 7. And so it's just 7-2. Yeah, that's right. This is how I worked it out. Camera over a little bit. There. So you guys are getting it. That's great. Now what we're going to do is, I've got another assignment. I think we're calling it homework 5 now. The homework numbers are matching the chapter numbers. I don't know if that will always happen, but that's the way it's been working out. So with homework 5, I have assigned all of the problems on page 50. I trust everybody has a copy of the book in some form, electronic or not. Is that right? So I feel at liberty to not type the actual questions since they're in the book. So there is someone who says here that they are able to compute the altitude of a hot air. No, it's a weather balloon. A weather balloon using some expression called equation 5.12-3, and that will give me the altitude. So let's get out of this my makeshift little USB desktop camera here. And we will look at the altitude. And I'll give you an example here. It says, what happens after 3 days? Show your results in 5-hour increments. No, in 1-hour increments. Okay, so he wants some sort of a loop in here. Let's see if we can do this. I think it's not too bad. I'll do the example for you. So this will be called, I know, let's call it 5 dot. I wonder if you can start classes with a number. I think you can. 5.6. Oh no, he doesn't like that. Okay, how about this? 5.6. There. You cannot complain about such a thing, I think. Is it easy to see in the back? You're very far away. You know, you can get closer. You don't have to sit all the way back there, you know. I would bring the screen closer, but I can only bring you closer to me. I can't come to you. It says here that he wants a 3-day increment. So what I will do is I will use my templates to speed up my typing. PSVM Control J gives me the template for public static void main string args. I don't know if you guys are up on the template thing in IntelliJ, but it can make stuff a lot easier. And so then he says 3 days, so I need some kind of for loop. For integer day equals, do we start with day 0 or day 1? Well, let's start with hour number 0. Oh, I know, let's do it with hours. That makes more sense. Hour equals 0, while hour is less than 72, hour plus plus. There, that's better. Right? Because he wanted it in 1 hour increments. And he wanted 3 days. And so then he says something like this. Oh, he's using the number t. Well, I guess if it's in days, t must be in days. So function is, or could t be in hours? Geez, you know what? It doesn't say. It says it's a function of time for the first 5 hours of flight. Show in 1 hour increments. T must be in hours. So, I mean, it makes a difference, right? And then what should the output be? The altitude is in meters. Dimensions are so important. Well, let's ignore the dimensions for now and assume that we are doing everything in hours. Because if we started doing this in seconds, we get some fairly big numbers quickly. So t is going to be squared, t squared, equals hour times hour. And now he wants also t to the 4th, which equals t squared times t squared. That should be t to the 4. And I also need t to the 3. So double t3. And that'll be equal to hour times hour times hour. That's fair. And now he says altitude is equal to minus 12 times t to the 4th plus 12 times t to the 3 plus, oh sorry, it's minus 380 times t squared t sq, and then he says plus 4100 times t, then he says plus 220. Oh, and this must be a double A, which has to be spelt correctly. There. I'm going to collapse this side here, and that'll let us see a little bit more of the screen. So now I think maybe we can write out the hour. How about this? Hour plus quote space quote plus and then the altitude. And see what we get. This is a classic example of garbage in, garbage out, because if this is supposed to be denominated in seconds, we'll have completely different numbers. But I think it will get too big too quick, because they did say this is going to be in meters. Wow, it's negative. Yeah, there is a minus sign in the leading number over in here. How big is 5,000 meters? That's big, right? That's like 15,000 feet. It doesn't seem that much. Isn't it about 3 feet per meter? Yeah, it's only about 15,000 feet. I don't think this formula is being used correctly, because hot air balloons should be able to go up perhaps 60 miles. I think so. So we have this basic question. Maybe this formula is not for a very good hot air balloon. When things start going negative, I have to think that the formula is not correct. So there's probably something that happens. It says for the first 5 hours of flight. And then what happens after 3 days? I think it must fall or something. Falls into the ocean and sinks. So for the first five hours, it's climbing, and then it looks like it's falling. Perhaps the balloon has popped, and it's been built into the equation. So that's an interesting point. When somebody gives you equations like this, we have a saying, garbage in, garbage out. You know the saying? You've probably heard it. If you don't know something like the dimensions and you don't know the units, and somebody just says, oh, the input is t. How do you know what t is? Is t in nanoseconds? Is it in milliseconds? Is it in days? I don't know what t is. So if he says tabulate it every hour and then look what happens after the first 5 hours, then you say, aha, I must have the right value of t, because after the first 5 hours he knew the balloon was going to pop and come plummeting back to Earth. So there's something about this equation that tries to model that. A is for, I'm just wondering if it's for acceleration. No, A is for altitude, and V is for velocity. But you know it's not really a velocity, right? Because velocities have direction, and this is just showing a magnitude, so it must actually be speed. So he's giving me an equation for both. So this is a legitimate answer, and I've come to the conclusion that it's all right. But it also makes a citation. It says, oh, you should go see Etter. And if you look at the back of the book, Etter is like a proper citation, I think. I hope. Unless it's at the back of the... Isn't there like a list of citations here? There may not be. I thought I had a proper bibliography. Oh, there's all these appendices. Somewhere in here there's a back. Yeah, here it is. So starting on page 684, there is literature cited. And Etter is a book called Engineering Problem Solving with ANSI C. So this is a borrowed problem from another guy's book, only done in ANSI C and translated into Java. Anybody going to have any trouble doing this? No? Easy, right? So then the next bit comes up and it says reference data types. What's a reference data type? Anybody want to venture a guess? In C you had to pass things by address, right? In Java we don't pass things by address, we pass them by reference. So we make a reference to a location in virtual memory. It's the moral equivalent of a pointer in C. So in effect, when you make a new instance of a reference, you have to do that at runtime, which means you're dynamically allocating memory from the heap. The heap comes from the Java virtual machine. Dynamically allocating memory from heap is an expensive operation. It uses a consumed resource. Once the resource runs out, you will get an out-of-memory exception at runtime. So if you make too many new instances of something, not only is it going to cost you time because you're allocating memory off the heap, but it's also going to consume a resource that will not be available for other parts of your program. Once the memory is gone and it's all used, it's gone. Now in C, you use malloc. Does everybody here know what malloc is? It's memory allocate. When you're done, so that you do not have a memory leak which causes your program to crash, good housekeeping dictates that you free by explicit invocation the allocation that you made. So you go to your pointer, you free it, and it goes back to the heap for some other program or subroutine to make use of. In C, Java has no free. Java says you set the reference up inside of some local scope, which we call a method. And once that method returns, any new allocation of memory has been released. It's harvested back to the heap using a background task known as the garbage collector. The garbage collector looks for unreferenced memory and says, mine, grabs it back. You can go to the system and do garbage collector immediate. Take a pause in your program, get all the unreferenced stuff, and put it back in the heap. Or you can let the garbage collector run in the background and it will grab onto memory dynamically as soon as it becomes available, according to the garbage collector. There are two levels of garbage collector in the Java virtual machine. One is the ephemeral garbage collector, which looks to see you set a reference equal to null, or looks for an immediate return from a method. The other is the background garbage collector. If you have a background garbage collector and it's waking up and running whenever, you're going to have what I call non-deterministic runtime. So what does this mean to you, the real-time programmer? It ain't real-time because you can't predict how long it will run. You cannot predict when the garbage collector will run. So if you want to do something really dangerous but real-time, turn the garbage collector off. What's wrong with turning the garbage collector off? It's going to create a memory leak if you start allocating memory after having turned it off. Eventually, you're going to crash your program because you'll be out of memory, and you'll get an out-of-memory exception at runtime, and your program will die. So, if you're going to be turning the garbage collector off, you've basically used this really powerful gun. And if you shoot yourself in the foot with it, well, that's on you, my friends. So, just keep that in mind. You can do it, but it's not necessarily something you really want to do unless you really know what you're doing. So this is one of those trade-offs. It's a basic engineering trade-off in Java. And if you wanted to turn the garbage collector off, you could say, okay, my program is now idle. Let's do a garbage collect immediately. Now you've become the garbage collection manager. And you've decided when to collect the garbage and when not to collect the garbage. So during time-critical portions of the code, it may be perfectly legitimate for you to turn off the garbage collector. I myself have only ever done it for fun. I don't do it because this is a routine course of programming for me. So I don't turn off the garbage collector. But you might need to. I don't know. Depends on your application. I don't endorse it. If you go to the system dot, I think it's GC. Yep, there's GC. And that's your garbage collector. Now the question is, what can you do about it? I think there should be some documentation. Runs the garbage collector. Calls the garbage collector virtual machine, expending effort toward recycling unused objects to make the memory they can currently occupy available for runtime, get runtime.gc. So I guess I could run the garbage collector. And then I don't think it will take very long because I've hardly allocated any garbage at all. Just print done. See how that works. Probably runs right away. Well, probably runs before you notice the delay, I imagine. Of course, the thing to do would be to allocate a whole pile of garbage and then check the memory and then do the garbage collection and then check it again. But that's a more exotic example. We don't need to do that now. On the other hand, it might be fun to try and make some reference data types. So let's do that. I'll do here's a bond computation. I'm just looking this over to see if there's any control structures here which you might find unfamiliar. I see a typo. Everybody here knows about for loops? Let's do the following. Let's create a class called certificate of deposit. A certificate of deposit has some principal involved, which we would call the present cost. So that principal would be expressed as a floating point number because it's in dollars and cents. So what we'll do is we'll give it double, well, it only needs to be double precision, floating point. So let's make it float, that's single precision, floating point number, principal. And we'll set it equal to 100.0. Now, what's wrong with this picture? How come I can't set this floating point number to 100? Well, if I make it double, it's fine. But if I make it float, Java doesn't like it. Java must be broken. Right? Java's broken. Who thinks Java is broken? Me. Java's broken. They fixed this compiler. They can't use this anymore. We have to switch to NetBeans. Anyone think Java is broken now? No? Nope. Well, then how do I fix it? You have to help me. Do what now? 100F. Okay, 100F takes the literal, which is defaulted by the compiler as a double, and says this is to be of type floating point, single precision. So what that means is that you're not losing any precision when you set it to a single precision value. So now I would like to have something, whoops, for my interest rate, and I'm going to set it equal to the common interest rate for nowadays, which might be perhaps as much as 2.3, and he doesn't like it again, so I better put in the F, and that makes it single precision float. Do I have to put in the F? What's an alternative? I could make it double, but I like float because I don't want to waste the 2 bytes. I'm very frugal when it comes to my bytes. How about this? How about if I make it float like this? So this is what's known as an explicit casting operator, which says to the compiler, convert it to a float, I don't care about the loss of precision, trust me. And the compiler says, okay, you can do what you want, as long as you know what you're doing. So now, suppose I would like to make an instance of my little certificate of deposit. I don't know if you're familiar, a certificate of deposit is issued by the bank to the lender, that would be you, the person who wants to put their money in the bank, and guarantees that you get a certain percentage, but will charge you a penalty if you withdraw early. So this could be a 2-year certificate of deposit. So this guarantees you 2.3% every year for 2 years. So in 2 years' time, you will have $4.60. But you will not have your $100 until then. So then you'll have $100 plus $4.60 if you would like to wait. So now, suppose I said to you, I'd like to make a new instance of the certificate of deposit. This will be my first reference data type. So to make a new instance, I will need a constructor. A constructor, just like in C++, has a method which matches the name of the class and returns nothing, not even void. So the constructor is certificate of deposit. Notice the return. It returns nothing. However, for a modifier, you can use public. That means everyone will have access to the constructor. Everyone will be able to make a new instance of the constructor. The class certificate of deposit extends the java.lang.object, which is the primordial class. A descender or subclass of the object class has the ability to be converted into a string. The toString method is implicit in the certificate of deposit. So we can override the toString method in order to make it say something when the certificate of deposit is printed. To override or shadow the toString method, I say public toString. Oh, and it has to return a string. toString. String is a reference data type. And what I can do is I can return hello world. Return anything you want, as long as it's a string. So now I can write some sort of a main method. PSVM, Control J, Enter. Make a new instance of a certificate of deposit. It will be a certificate of deposit type. We'll call our new certificate C. We'll set it equal to a new certificate of deposit, and then what we'll do is we'll put a print statement and we'll print it. What will this print? Hello world. It will print hello world because an invocation to the system.out.println method will in turn invoke the toString method, which will in turn return the hello world string, which will then be emitted by the print line. In theory. Because I made a new instance of the certificate of deposit, it's going to allocate memory from the heap. Suppose you wanted to change the behavior of this toString method. Suppose you said, I know, let's turn it into toString, and it takes an integer, t, or something like this. Now if you run it, it will give you a completely different behavior, because it's no longer invoking the toString method without an argument. It's invoking the toString method in the primordial object class, and that is going to return the reference address right in here, as well as the fully qualified class name, which says that the certificate of deposit is a class that resides in the control structures package, which resides in the book examples package. And that's what the dotted notation means. So if you're looking in terms of folders, you'll see there's a folder that says book examples, into which there's another folder that says Chapter 5 control structures, into which there is another folder that says there's a class inside the folder called certificate of deposit, and when you made a new instance, its address came out to be this funky little number. As a matter of fact, that number will be different for each instance you create. So if you wanted to, you could copy, paste, print it again, only instead call new certificate of deposit. Oh, I put a extra T in there. And you should get two different numbers. Those are hexadecimal numbers, by the way, which we now know how to convert to binary, should we want to, or even octal, hexadecimal. So those are, as you can see, rather different numbers. Moreover, they don't even appear to be all that close to one another. They're pretty far apart. Totally different instances of the same class. It's the moral equivalent of having two different cookies made from the same cookie cutter. Right? You don't eat cookie cutters. You eat cookies. So you can keep stamping out cookies, as many as you like. You can stamp them out like M&Ms, and then you can eat them all up. And it will make you fat, because each cookie has its own calories. And when you eat it, it adds to you. It makes you fatter and fatter until eventually you'll need a bucket. So if you're thinking in terms of making a new instance, this certificate is not the same as this. They are not equal in terms of equals equals. I can use IntelliJ to introduce a variable. Oops. I'm having issues with my trackpad. Extract variable, and we'll replace this instance only, and we'll give it a new variable. We'll call it C2. Enter. So this is interesting. Let's create a Boolean, and we'll set it equal to Boolean B, and it equals C equals C2. S out, Control J, enter, B. Okay, that's very interesting. Does C equal C2? Are they the same? They give me the identical principal. They have the identical interest. Why aren't they the same? Shouldn't they be the same? Isn't C equal to C2? Aren't they the same certificate? Remember the cookies and the cookie cutters. Two different cookies. So at runtime, we don't think they're the same. So then the question becomes, how do I know if this cookie is equal to that other cookie? Well, in that case, you want to use something like equals. C dot equals C2. So, if it's using equals, what is equals? I don't understand. Does equals do anything? It says here equals determines whether one object is equal to another. So when you use equal, you're comparing references. When you use equals, you can actually compare values inside. So suppose you wanted to compare apples and oranges. Apples can't be equal to oranges unless you have some basis for comparison. Right? So maybe you'd say, well, they're equal if they have the same calories. So now you have to override how equals behaves. You said they're equal if they're the same price. Now I can compare apples and oranges. Right? I can say, well, apples cost more than oranges. Right? And then you could say, well, maybe, but it depends. Maybe they're not in season. So let's see what happens now if we run this program with equals. What could possibly go wrong? I see red lines all over the place. Oh, they're not equal. So how can I make them equal? I want them to be equal because they're the same. They're not the same. They're two different instances, but I want them to be compared as though they're the same certificate of deposit. So what I will do is I will say public Boolean equals. And then when I pass in a certificate of deposit, I will compare one certificate of deposit to another. So I've got my principal C dot P. My principal has to be equal to the other guy's principal. And my interest has to be equal to the other guy's interest. So what this says is the principal P, which is local to me, is going to be equal to the principal of the other guy. And the interest I, which is corresponding to my interest, has to be equal to the interest of the other guy. Now when the two interest rates are the same and the principals are the same, then the certificates of deposit come back as equal. Two different certificates, two different addresses, two different cookies, but they're being compared by whatever criteria you select. So you have to decide how you're going to be comparing your objects. You might say that you could also compare them not just for equality, but for whether one is greater than or less than some other. In this way, you could sort the certificates, which might be very compelling, especially if you have some criteria that allows you to determine whether one certificate is greater than another, such as time to maturity. So now I've got my certificates, and they're all printing hello world, or they print some random wacky nonsense number. I don't really care for the wacky nonsense number, so I want to change it so that the principal and the interest are printed. So perhaps I can do it this way. P equals, end quote, I think it's this way, quote, P equals, end quote, plus P, plus, quote, comma, space, end quote, plus, I know, I equals, end quote, plus I. What did I just do? Well, it's going to say P equals, in quotes, then it will get me the value for the principal, then it will say comma space I equals, in quotes, and then it will get me the value of the interest rate. It returns it as a string. It does it automatically upon invocation of the toString method which is done by the system.out.println. So when you call system.out.println with an instance of a certificate of deposit being passed in, it invokes the toString method and then does the let's find out the value for the principal and interest and put it into a big string that we can then get a reasonable representation for our certificate on. Two different certificates could have the same principal and same interest, in which case the two are equal, according to the way I define my equals method. Am I going too fast? Is everybody sort of getting this? Who's lost? Be honest. So now we can see, aha, there are two certificates. One is $100 for its principal and 2.3% interest, and the other is perhaps the same values, but they are different certificates, clearly different, and they can be compared, even though they are different certificates, and we can compare them based on principal and interest rate, and that's legitimate. What do you think of that? Good, right? Everybody's with me on this? Nobody's lost? Really? Really? Okay. So, the constructors all have certain things available to them. One thing that you can mention in the constructor as it's being printed is you can go out and you can get the name of the class. So let's say you have a C dot get class. This is interesting. So get class on C, that's the class from which the reference data type C was created. It is of type class. And we can give it the name, I hate to call it class. How about we call it something else? The cert class. So C.getClass is an interesting thing. C.getClass allows us to gain access to the cookie cutter from which the cookie was created. Now I can know about the class. What can I find out about it? This is very interesting. So I go into the cert class and I can get the name. I can get information about the class from which the instance came. And when I get that name, it comes back as a string. And now, I think maybe we're ready to print out the name. So that should be the name of the class from which the instance came. The name of the class. I'm thinking it's called cert of deposit, but in fact there's more to it than that. It's a fully qualified class name, which means it includes the packages which contain the class. So when you look at something like the declaration for this class up here on the top, what you really see is something very interesting. It says it's in a package. It's in a package. That's interesting. What's a package? A collection of classes. Okay, that's fair. It's actually a way in which to organize the classes so that they can have a directory structure with a, I'll say, within a file system. So you can have directories within directories within directories. Oh, that's interesting. So let's look and see how that's organized in terms of our project. I see book examples, and inside of the book examples folder I see chapter 5, and inside of the chapter 5 folder I see certificate of deposit. So indeed, it is the case that I can find the certificate of deposit nested within these folders. Moreover, if I'm of a mind, I could probably go in and find the same exact thing using the file system. So here's the Lion directory, and there's the J4P directory, and here's the source directory, and there's the book examples directory, and here's the chapter 5 control structures directory, and now I have the certificate of deposit. So what the package has done is it has correctly reflected the location of the class within the file system relative to the project. It didn't give me a fully qualified file name, which would have started with something like C:"lion:" J4P: SRC: book examples: chapter 5 control structures. Instead, what it did was it said relative to the source root, this is the location of the class, and the source root contains the book examples. So there's the source root, and here's the book examples. So everything is relative to the source root. But there's more. Java compilers input source code, but what do they output? I think we had a homework on this, didn't we? They output what? EXE? No. They output bytecodes. Java compilers output bytecodes. Ahead of time compilers can output EXE. But just-in-time compilers, the ones we're used to, JAVAC, they output bytecodes which are put into .class files. But wait, all we've seen is source files. Where did the class files go? Where are these class files? How do I find them? What's going on? Somebody told me Java compilers output class files. I want that. Where did that happen? So I need to go find those class files. Let's play Find the Class Files. So it turns out I've got a directory called Lion, named for me, and then another directory called J4P, which is my Java for Programmers project. And when I look at it, it says, aha, there's a directory here called out. And in the out directory, I've got production. And this is created for me by IntelliJ, so it won't necessarily be the same for NetBeans if you're using NetBeans. Or is anyone here using Eclipse? Nobody uses Eclipse? Okay. There are other IDEs. So now if I look, it says, aha, J4P in production, and now I can see book examples, chapter 5, let's pipe it into more, and now I see certificate of deposit, sure enough. So the source code is separate from the bytecodes, and when you want to run the certificate of deposit.class, you cannot run it right here, right? You can't just say Java CERT of DEP, because he can't figure out how to decode that class. Instead, you have to run it from the root of your bytecodes, and then you can say Java book examples dot chapter, oops, I think you need a backslash, chapter 5, oops, I'm going to write 5 backslash certificate, I think it's capitals, certificate of deposit, and then you take out the dot class part, and now I think maybe, what's his problem? Maybe I need to put in the dots, right? He really wants those dots. Dot, backsplash, I just didn't want to type it all, so I used the backslash and let Windows help me type it. See if that works any better. Yep, works good. So within the command line, the Java virtual machine is expecting to see the byte codes in its present directory using fully qualified, I'll call them class names. The equivalence between the class names and the folders are obvious to us as programmers, but the Java virtual machine is using a dynamic class loader to go through the file system in order to be able to find those byte codes, load the class, and then run them. So when you say, geez, how did the Java virtual machine find the byte codes? The answer is because the Java virtual machine is using a special global variable called the class path. It's the same way the command line interpreter is able to find exe files under Windows. It uses the path, right? So when you look at the path, this is the search directory used by the command line interpreter in order to find all the exes. If you use the class path, you see it's not set. It should be set. So if it's not set, it's going to use the default directory. When you use Java-CP class path, you can set the class path to anything you like. And you could give it a fully qualified file system name, like C:, blah blah blah, and keep going. I guess it's this way. C:, \lion. Isn't that how they do it? J for P. Oops. Out. Production. What a pain. J. Book examples. Well, I guess you can just stop there. And now you can see the options here, which is actually very nice. Pipe into more. Oh, it didn't stop it. There's no good way for me to scroll back. Oh, maybe there is. Yeah, CP is the class path for the search directories, and it can include zip and jar files. So if you take all of your byte codes and you put them into what's known as a Java archive or a zip file, put it into the CP argument, and the Java virtual machine will find it. So that's kind of a convenient thing. And this is a list of all of the folders that contain classes as well as some classes. I think this will work. Emacs is an editor, and what you can see with the editor is that I can navigate through to the byte codes, and then I can actually look at the byte codes. And this is what the Java virtual machine is inputting. And you can see right in over here a fully qualified reference to a string. We can see the equals. There are some non-human readable byte codes in here. But this is what the Java compiler outputs. It's essentially given us a compact form for the program. So that's the shtick. What do you think of that? Good, right? Is it time for a break? You guys are very quiet. Want to keep going? I can do this all day. No? Take a break, right? Yeah, let's take a little break. We'll break for 5 minutes if that's okay. Thanks.